Hi everybody, this recording is for Friday, September 20th. As I previously announced, we're not going to be meeting in person today, so this recorded video will be posted on YouTube and I'll upload the link to Blackboard. Just a couple of important reminders about Monday. That homework 5, which is a couple of relatively simple bond-related problems, which I've provided the answer to so that you know if you're headed in the right direction on that. That assignment should be uploaded to Blackboard before noon on Monday. And then noon on Monday, we're going to have our first midterm exam. Remember that you need to bring your computer to the exam. You're allowed to prepare a page of notes front and back with formulas, equations, whatever you like to put on there. And then I myself am going to be providing you with the factor equation sheet, as well as any factor tables that you'd be asked to use for problem solving. So that's exam 1. And if you have any questions about that, you can feel free to email me and I'll get back in touch with you. Today's lecture is a continuation of the discussion we had on Wednesday about bonds. And then I'm going to be introducing the course project, which is available on Blackboard right now. You can see the assignment description, the parameter assignments, and so on. The remainder of this video was recorded last year in a previous semester, and so the material hasn't changed, but there may be some incidental references to dates and times that don't align completely with what we're doing this semester. But the thing to feel assured about is that these announcements that I've just given you today are what you need to be focused on, and we'll talk more about the course project after the exam as well. But it is really important that you listen to this video and understand the project, because this is going to be the primary and main emphasis on how to complete the exam, and that's a big part of your grade. So with that, we'll get into the video. And again, please let me know if you have any questions. And just in case it's useful, let me revisit that one briefly. Problem 2 was a question where you were told the face value of the bond rate. Sometimes another word for bond rate is coupon rate. That means what does the organization that you've loaned the money to actually pay you in terms of interest. This mentioned that the bond interest payments were paid twice per year, 25 years. They're redeemable for 200. So the redemption price and the face value of this bond are different. Oftentimes they'll be the same, but in this case, just for illustration purposes, they were different. And because there's 2 different rates in problems related to a bond, there's the interest rate that's being paid out by the organization that you're loaning the money to, but then there's also the yield rate. And the way that the yield rate can be different is if you purchase the bond on the secondary market for something other than the original issue price of the bond. So you can get a different yield that varies from the bond rate or the coupon rate. So here we had a defined yield that we were trying to achieve of 5%. So if you wanted to achieve a 5% yield per year, this one, what we did was added together the 2 components of value in the bond. And remember that a bond's 2 components of value is the value of that lump sum payment at the end of the bond's life. So it's the present value of the redemption price. So in 25 years, you get $200 as a lump sum payment. The present value of that future amount is only $58.19 if we're discounting that $200 each period by the yield rate. So every period, as we discount that backwards from the future value lump sum to a present value lump sum, $58.19. And then the other component of a bond's value, remember, is the present value of the periodic interest payments. And that's a uniform series. So we apply the find P given A approach. Now, the formula that we used in both of those was the PV function. But where we put the amount that went into the PV function was different, because for this first component of the bond's value, where it was a lump sum in the future, some years, we put the amount that was going in of $200. You'll notice and remember, I hope, that that went into the future value,
field of the PV function. But because the interest payments are an annual series, meaning that they recur the same amount every time uninterrupted, that's an annual uniform series. And so that goes into the PMT field. That doesn't go into the FV field. The FV field is for some lump sum future amount, whereas the recurring payment should go into the payment field. So we found the two components of value, and then 150.37 is the current value of the bond if you're trying to achieve this 2.5% yield per period. So if you had different assumptions about what yield you're willing to accept, then that would increase or decrease the price that you want to pay for the bond. So does anybody have conceptual questions about bonds, or maybe about this example problem in particular? All right, so the one that we didn't finish last time was this question. Question 3. A certain bond will pay $55 4 times per year for 10 years, followed by a lump sum payment of $1,000 10 years from today. The bond price is $900, then what is the yield of the bond? All right, so let me just write on the board some of the variables that we've defined in problems like this before now. There's been N, which is the number of periods, R, which is the bond rate per period, I, which is the yield rate per period, C, which is the redemption price, Z, the face value, and then below that, I've been calculating R times Z. So let's see what we know and what isn't defined in this statement. So first of all, it says that the bond pays $55 4 times per year for 10 years. So what does that tell us about N?
4 times a year.
4 times 10, so N should be 40. There's 40 compounding periods that occur. Does it tell us what is the coupon rate of the bond? What does it tell us about the interest rate of the bond? How much are the people that we're loaning the money to, how much are they paying us? $55, but they're not expressing that in terms of a percentage in the problem statement. So we don't have R specified, but that's okay. I'll show you why that's okay in a moment. Yield, I. Well, that's the main question. What we're trying to solve is the yield. So I'm going to put a question mark. Solve for this. We're solving for the yield. Okay, C, the redemption price, 1,000. So that's going to be the lump sum that we get 40 periods in the future. And what about the face value? We know the redemption price, but we don't know the face value, Z. So that's also not defined. So we don't know R, we don't know Z, but we do know R times Z. What is R times Z? Well, that's the interest that you get every time they pay you interest. So it wasn't expressed in terms of a percentage, and they didn't define the face value of the bond, but what we do know is that there's every time interest is getting paid, meaning 4 times per year, $55 is being paid. So R times Z is, by definition, your interest payment. So that's enough. That's actually all we need to solve this problem. So let me show you how we could set this up in Excel and solve for the yield of the bond. Any questions before we move forward? Okay, so this is that problem. And let me just set it up structurally the same as the other one that we did so far. So there's N, R, I, C, Z, and then below that I had R times Z. And then just to copy the definitions from before, let me do that as well. So here's the definitions, and then this is the amount of interest that gets paid each time. All right, so N is 40, R We don't know that. The I is, we're going to solve for this. So let me just here in terms of annotating the problem, this is what we are trying to find. You know, it's a good habit to put these little notes in to show that you know what is the process. You know, to draw the grader's eye to the fact that you understood, kind of like you're showing your work. And also, it'll remind you later on if you leave these little breadcrumbs for yourself on how to solve the problem. So we're solving for the yield rate per period. So we'll start with a guess. We're going to iteratively solve for the yield. So is it 1%? I don't know. But let's just start with 1%. And we're going to be doing a goal seek. And so we'll be constantly changing I until we get the right answer. Redemption price is 1,000. Let me format that as currency just because it is money. The face value, not defined. But R times Z, each time interest gets paid, it's $55. All right. So now, who can remind me, what are the two components of a bond's value? P given F, and so that's the present value of the redemption price. All right, so that's one part of the bond's value, and then what's the other part of the bond's value?
P given A.
P given A, the PV of the interest payments. All right, so let's calculate those two things with this hypothetical 1% yield. Like, how much would the bond be worth if it was 1% yield? Okay, so equals PV, the rate, at 1%, comma, for 40 periods, comma. Now, this redemption price at the end of the bond's life, should I put that in the payment field or in the future value field? Future value. It's a lump sum amount. So I'm going to do the double comma to skip over payment and minus of the redemption price in as the variable for the future value. Okay, so if it is 1% yield, then that $1,000, 40 periods in the future, has a value today of $671.65. Okay? Then with this if, let me just make this yellow to emphasize that there's something special about this cell. This is a cell that I'm going to be changing around iteratively using goal seek. So these values that I'm calculating are just dependent on what is right now simply a guess. So equals PV of this guess interest rate, 40 periods. Okay, now the interest payments, which field do they go into? PMT or FV? They go into the payment field because they're recurring, ongoing, regular, uniform series amounts. So every time the interest of 55 gets paid, we want to find out what's the present value of 40 of those. So find the present value of 40 interest payments. So it's kind of like we get $55 at 1, $55 at 2, $55 at 3, $55 at 4, $55 at 39, and $55 at 40. And then there's also a lump sum, so A equals 55, and then the lump sum is 1,000. How much is that worth as a lump sum today at 1%? So really what we're trying to find out is not how much is it worth at 1%. What we're really trying to find out is at I equals what is the P equal to 900. So what we'll do is we're going to set this up to calculate P at 1%, and then we'll get some present value. It won't be 900. But then what we're going to do is we're going to keep changing I until P equals the 900 that we know we're going for. Okay? So what I'm doing right now is I'm finding the present value of the interest payments. So here's the present value of the lump sum. Here's the present value of the interest payments. And the sum of those two things, the total present value of the bond, is this and that together. So we want to know what I gives this total value equal to $900. Well, 1% isn't the interest rate that makes this 900, because right now it's too high. So what if I changed it to 2%? Is it getting closer? Yeah. 3%? Closer. 4%? Closer. 5%? So I'm getting awfully close now. Rather than just keeping to type it in, which, you know, I could do. I could manually iterate until I get to the interest rate that I'm looking for. That's too big. 0.15. That's getting awfully close. What I can do is here on the top ribbon, do data, and then what if analysis, and goal seek. And what I want is this total to be 900 by changing the interest rate. And then when I give it the freedom to do that calculation, it finds that the interest rate that would give me the bond value is equal to 900 is 6.1797 yield per period. So the question was asking, if the bond is being sold for $900, how much yield do you get? And you get more yield than just the value of the interest payments, because you're not only getting the interest payments, but you're also getting $1,000 in the future, whereas you only paid $900 now. So part of the profit, so to speak, is the periodic payments over time, but then part of the profit is the difference between the purchase price and the redemption price in the future. So with what I've just showed you here, you can solve a couple of the homework problems that ask you to do a similar thing, where what you're going to be doing is playing around with the interest rate, which will in effect change the PV of the redemption price, it'll change the PV of the interest payments, and you are trying to find out at what interest rate do you get a certain total present value of the bond, being the sales price. Okay, so any questions about that? All right. If not, then we'll spend some time to talk about the project. All right. How many of you want to spend the rest of your lives in a cubicle? 7 days a week. You want to spend your whole life in the cubicle. I don't see anybody raising their hands. Maybe somebody does, but I think most of you probably have other things in mind. You know, there's the weekends where you're not going to be sitting in the cubicle. There's the evenings where you're not going to sit in the cubicle. Maybe you'll retire at some point. But what society tells us, and like the job market and your debt obligations, there's a lot of forces in this world, even conventional wisdom, that is going to be pushing you towards maximizing how much time you spend at work. Like your boss will give you positive feedback when you're very productive at work, and that'll be gently encouraging you to work more, work harder. Maybe you'll have a genuine interest in your work, and you'll have a hard time drawing the line between your personal time and your work time. But maximizing time at work, believe it or not, does not maximize your happiness. And I know that I mean, nobody is surprised by that. Everybody knows already that happiness and productivity at work are two dissimilar things. But as clearly as you know it now, you'll start to forget it. The longer you're working, you'll start to value yourself in terms of how well things are going with your career. Now, the project that I'm going to be giving you, the title of it is Die with Zero. And it's based on a book that was written by a guy his name's Bill Perkins, and he's a multimillionaire. He may be a billionaire. He made his fortune in the natural gas trading industry. He was a Wall Street trader, and he bought and sold natural gas futures, meaning that like when people were expecting natural gas prices to go up, and he had contracts for the delivery of natural gas in the future, he'd profit from that. Or if he knew that natural gas prices maybe were going to be going down, he would make moves that basically rewarded him when he was able to predict what was going to happen with the price of natural gas over time. So he's made a lot of money, and he's very successful, but through his life, what he recognized was that financial success and personal satisfaction were two distinct things. And he tells the story in his book about a colleague of his at the natural gas trading firm he was working at who just vanished for 6 months. And this was when he was in his 20s. Like they were mid-20s, and Bill Perkins was working every day, and this other person just went to Europe and was gone for 6 months. Basically dropped from the company, kind of put on an inactive status, not drawing a salary. Everybody forgot about this person, but he had amazing experiences. And Bill Perkins talks about how he's been jealous about that person having those experiences when he was young, because what Bill Perkins talks about is that it's not just the experiences you have in your life, but it's also the order that you have them in, where a person who's in their 60s isn't going to have as much fun, sleeping in youth hostels in France and going out drinking late and going windsurfing, all those things that are fun and attractive to a young person. Once you become older, maybe aren't physically possible because of the way that you've aged, or maybe you just don't have the energy to do those things anymore. So the point that Bill Perkins makes in his book is that you should design your life for maximum satisfaction and maximum happiness, that you shouldn't design your life to maximize your wealth. And he says that too many people get into the mindset and the trap of maximizing their wealth at the expense of other experiences that would be more meaningful. So he specifically talks about people who skip their kids' Little League games, or people who miss performances that their kids are in so that they can focus on work. Bill Perkins talks about people who only take a minimal amount of vacation, and they don't take the time that they need to recharge their batteries or experience the interesting things that can happen when you travel internationally or so on. So what he basically says is that you should design your life so that you have enough money to do all of the things you want to do, but you shouldn't have any left over. So he calls it die with zero, because his philosophy is that on the day you die, you should have no money left. Like, that's the perfect life, is the one where you worked just barely enough to cover all of your expenses, where you worked just barely enough so that you could take care of the people who rely on you and depend on you, but then you invest the rest of your time into leisure activities, invest the time into maintaining good health, and that you find more of a balance in life on the things that you enjoy. Whereas what society says is, just save, save, save. Like, there's never going to be too much money in your retirement account, according to what conventional wisdom and society says. And what Bill Perkins says is, when you know what you want your retirement to look like and how long you want to be retired, you can buy annuities and insurance and other financial contracts that will secure that future and put the uncertainty in someone else's hands, so that you can have a comfortable life and maximize your enjoyment. So, like in the eyes of Bill Perkins, if you have leftover money when you die, what that means is that either you worked too much or you didn't give away money early enough. And he makes the point that, it's a good thing when wealthy people, for example, donate $1 million to charity when they die. But it would be even better if that money was donated to the charity before the person died, because number one, the charity could have been doing things earlier and sooner and made more of an impact. But then also the donor would have been able to see and enjoy the fruits of the donation that they'd made. And so it would be more of a win-win situation to give away money, if you're going to give away money, early as possible rather than leaving it to the very end. So maybe you're convinced by the theory, maybe you're not. What I'm going to do is I'll give you a link to an interview that Bill Perkins did with a podcast host. And if you really want to take a deep dive into the ideas of the book, then watching that podcast, I think, would give you a good idea of why he has that philosophy. You don't strictly need to do it for the project. The project, what I'm going to do is assign you several scenarios to consider. And the scenarios are focused around these philosophies in the Die with Zero book, which I've kind of already talked about most of these, but let's just go through them one by one. Maximizing positive life experiences rather than maximizing your wealth. And the way to do that is if you invest in experiences early, what Perkins says is you get to think about them for the rest of your life. So if you go to Europe when you're 20, then you've got a whole lifetime to reflect on that trip and think about it and have it maybe not only just pay like warm fuzzies in your heart, but also you may learn things, you may have experiences that guide the rest of your life, and so you'll be receiving compound interest on that investment if you do those things early rather than later. So I've already explained that he says you should die with zero because if you have leftover money when you die, in his view, that means you worked too hard and you didn't need to work as much as you did, or you didn't give away the money soon enough. I guess the only other thing that I'll mention is the idea of taking big risks early rather than later. And the reason why he says that you should take the big risks early is that now you have fewer obligations than you will in the future. So when you're young and you don't yet have a mortgage, you don't yet, in many cases, have family obligations or professional obligations, it's much easier for you to do that wild thing that you've always wanted to do when you have fewer obligations than when you're trying to arrange child care, pet care, someone to look after your house while you're out of town, all those other sorts of things. So I will provide you the link to listen to the podcast, and I think it's excellent. It's really different from what most people say, and it's changed how I think about my financial planning for retirement. But what I'm going to ask you to do is assess a hypothetical person where I'll be giving you their assumed income, I'll be giving you their assumed expenses, I'll be telling you how the investments go up and down each year. I'll be telling you what to assume for how their income changes over time. So I'll show you what that looks like in just a moment. But as a base scenario, what I'll ask you to calculate is how much money do they have in their investment account balance at the age of 85. So just to find out that pot of money, their total wealth, assuming, simplifying things, assuming that all of their wealth is in one account, how much would they have if they worked until the age of 85? And hopefully most of you won't work that late. 85 would be a terrible age to work. Now, as a second scenario that you're going to assess is what if the person retires at age 67? Now, this is a different analysis from the first analysis, because what the first analysis had them doing is working and receiving income all the way through age 85. In the second scenario, at age 67, they switch over from work income to a pension, like Social Security, where they're still getting income each month, but it's much less than before. And so what we want to know is how does their investment account balance go up or go down through the years if they retire at age 67? So there are correct answers for both of these, and I'll know what they are. The third scenario is if you wanted to do this thing of dying with zero at age 85, then at what age could this person stop working? So like if they stopped working at 60, for example, then what does that mean by the time you get to 85? Have they run out of money? Like, is it a negative account balance at age 85 if you make the transition from working income to retirement income at age 60? If it's a negative balance, what that means is the person needs to work more years. So they need to work to 61 or 62 or 63. So I want to find out at what age could they continue to work and then stop working if we want to die with zero. The fourth scenario is how much could the person donate to charity each year if they work till age 67 and then die with zero at age 85. And then the fifth scenario is unique from all the rest because what I'm asking you to do is develop your own plan. So the first four analyses were based on some hypothetical person that you're just analyzing. In scenario 5, you are the person. And so I'd like you to put your own savings or debt as the starting point. I'd like you to make a rough assumption based on available data on what your income might be when you graduate, and develop just a quick budget that lists what your expenses would be in the city that you expect to live after you graduate. So by personalizing this, what you'll be able to do is continuing to use the details that I provide of income growth, expense growth, and so on. You'll be able to find out at what age you could hypothetically retire in order to have that die with zero scenario at age 85. All right, so before I open it up to questions, and I'm sure that there probably are some, let me show you the starting point spreadsheet that I'm going to be giving you. It's already on Blackboard right now. If we go to Blackboard in the courses page, there's a new folder that I've just created called the projects folder. And here in the project folder is the handout. I might as well give you the handout right now. I printed a copy of it, so you've got that available. I've got very positive feedback on this project in past years when I've done similar ones. I adapted each semester to try and make some interesting tweaks and adjustments. If there's any extras, as always, just please pass them back towards the back of the classroom. Okay, so the handout is online, and the handout has the link. I'll also be emailing you the link to that podcast. It's a really excellent discussion. This also describes each of the 5 scenarios. So the 5 scenarios that you're supposed to assess, I explained that the deliverables on the due date is a write-up where you mention the answer to the scenarios 1 through 4 and then explain your assumptions for scenario 5, tell me the answer, and then the spreadsheet itself needs to be provided as well. Okay, so let me show you what the spreadsheet file looks like that I've got. So this is available to you now online. If you download it, what you'll notice is that there are 10 tabs. And each of these tabs is meant to correspond to the last digit of your ID number. So if your Marshall University ID number ends in a 0, then you use tab 0 for your calculations. I did that to kind of scramble. I didn't want everybody to have the same answer. That would be kind of boring. So there's 10 different scenarios. Each of them has a different starting savings amount, different income assumptions, different expenses, different assumptions related to growth of investments and so on. So first of all, does everybody understand why there's 10 different tabs and which one to choose? I hope so. So, for example, if your Marshall ID number ends in 1, then you'd use this this one, and you delete the rest. So you don't need to have any of the other ones if yours is tab 1, and in fact you should delete the other ones, because when you submit your answer, I don't want there to be a bunch of extraneous pages that don't apply to your calculations. So if you want to use this as a starting point for your calculations, you're welcome to. You don't have to. But let's see this person, what we've got. This person, when they graduate, this says they'll have $8,000 in starting savings. The first year that they work, they get $58,000. One of their expenses is going to be income tax, and so 15% of their income goes as taxes. Their other expenses, you can see, are listed here. This is all per year: housing, food, entertainment, and so on. Expressed in terms of the first year, because as you'd expect, over the course of a 60-year lifespan, the living expenses aren't going to be the same every year due to inflation. So this is just in the first year what the expenses are. And down below here, I explain how the living expenses have changed from the previous year. So during the first year, for example, if we added up all of these living expenses, down here at the bottom it says the sum is $45,200. So the expenses are $45,200, but that's just the expenses during the first year. In the second year, the expenses are going to be 1.2% higher than the year before that. And then in the third year, it's 1.1% higher than the previous year. Not higher than the base year, but the living expenses continue to compound and get higher and higher. So all of the different tabs have different data in terms of from year to year how your living expenses are changing. You'll notice that there's income growth because there are going to be years when you get a raise due to a promotion. Or maybe you'll get a raise when you become licensed as an engineer. Or maybe you'll just get a cost of living adjustment that's not tied to performance at all. It's just related to the fact that there's inflation and the employer is giving everyone an across-the-board pay increase to cover the cost of living. So that's what this column is it's going to tell you, you start by earning $58,000 a year. That's in the first year. In the second year, you're going to earn 2.2% more than that. Okay? And then the last column here says the rate of return on savings. They always say that you should assume the U.S. stock market is going to return over the long term 7.8%. Some people say that's like a pretty typical value of what the stock market will do, 7.8%. But it's not even every year going up 7.8%. Some years it goes up, other years it goes down. So that's what's happening here. Some years it'll go up a lot, some years it'll go down a little bit. And so what we want to know is, what is your investment account balance at the end of each year? And I give you the formulas here, like how much money you can save. Well, how much you're able to save is the difference between your income minus your income taxes, minus your living expenses, minus your gifts and charitable donations. So if I was going to draw it as a box, this is a box where all of your money goes. Money comes into the box. Money goes out of the box. If more money is coming in than going out, the balance will increase over time, particularly if there's a reaction happening inside that box. And the reaction that occurs in financial terms is compound interest. And so your investment account balance in a given year is the previous year's balance multiplied by the rate of return on savings, which is this column. So let's see, in the second year, 15.8%. What that means is that whatever balance you had at the end of the first year is going to earn 15.8% return during the second year. But the total investment account balance at the end of the second year is last year's balance plus the interest plus how much you saved this year. So you'll notice in this formula there are three terms. There's the interest that you made, There's last year's account balance plus the amount that you saved this year. So any year that you have more income than expenses, that investment account balance has the potential to increase unless there's a big decrease in the rate of return on savings. So when the market goes down 18.6%, even though you put money into the account, the overall account value may decrease if the rate of return on savings is negative. But that's painful. When you look at your retirement account and it's less than it was last year, even though you've been putting money in every month, that sometimes happens during economic recessions. And that's what this kind of simulates, is ups and downs, but the overall average here would be, for this particular scenario, 5% rate of return for the savings. Okay, so let me open it up if you've got questions, because I've told you a lot of things so far. Any questions about the spreadsheet or about the 5 scenarios that I'm going to ask you to assess?
So would you want us, when we're solving it, would you want us all to keep them all on the same spreadsheet when you're doing it, or would you rather have us create a new spreadsheet to put all the information on there to just keep it separated to make it easy to read?
My recommendation is that you use a different tab for each of the 5 scenarios. So like this would be your scenario 1 tab, and then you could copy it, and the next scenario would be on a different tab. So scenario 1 here, scenario 2 there, and so on. It'll be simplest that way. Are there other questions? So you're going to need to do a little bit of research to find out, what does a software engineer make in Cincinnati, if that's where you plan to live and that's what you plan to do. Or what does a biomedical engineer make in Boston? And what are the living expenses in Boston? You're going to have to personalize this a little bit for scenario 5. I mentioned in the handout that if you don't want to actually put your actual savings in there, if you want to keep that financial information private, that's totally fine. I don't really care. Just put some value, and it may be negative. I mean, I know a lot of people who've taken out student loans are starting not with a positive savings balance, but you're starting with debt. And that's most people are going to have debt. So your starting savings in that account maybe would be minus $15,000 if you've got student loans that you're going to be paying on. And you'll see that your cumulative savings balance over time is going to go from negative territory to positive territory.